and thank you for joining us today. I am with Phil Estes, a distinguished engineer at IBM and also the maintainer of the Containerd project. Hello, Phil. Thank you for joining us. How are you?
Great. Yeah, glad to be here. Thanks for having me on.
No, this is awesome. Containerd is one of those projects where I am familiar with it. It exists. I am familiar that I'm using it in production, and I don't really know much more about it beyond that. So I'm looking forward today to getting into some of the details of how Containerd works and why it exists.
Awesome. Yeah.
Excellent. So I think let's just start with a viewer question because I think it is important, and I may already have made my first mistake of the stream, but this person asked on Reddit prior, how do I pronounce it? Is it Containerd or is it Containered?
Yeah. So the project officially we call it Containerd, but it's definitely been an inside joke or not so inside joke that we call each other Containerds. So yeah, officially the project name is definitely Containerd. Thinking, how systemd and other daemon-like processes are called. That's kind of the nomenclature.
Right. See, sometimes you just don't think about that, but I think it's so prevalent, especially in the technology community. We have so many projects where you don't always know the right way to say it. We always have these weird debates around is it MySQL or MySQL and all this thing. So I think it's good that we clear that up for sure.
Yep.
All right. Do you want to, if you don't mind, just give us a little bit of the backstory then? How did Containerd come to exist?
Yeah. So, I think the easiest starting point is to think about, Docker's rise as a developer tool, in that 2014, 2015 era. It was really easy to use and install because essentially that single binary, at least, speaking in Linux terms, there wasn't Docker Desktop, there weren't all these other products around it. It was just Docker, and Docker, the tool, could easily be put on any Linux system. It was statically linked. You didn't have to worry about your distributor giving you the right version, linked to the right libraries. And it was sort of an all-in-one tool. It had registry support. It had ability to build containers. It ran containers. And obviously, over those next few years, there was an explosion of features, and there was also, some community tensions around when Swarm got added and Kubernetes was coming on the scene, or effectively was already there, but rising in significance and usage. Out of all that, you also had people with other ideas for what a container runtime should look like. And so out of that, the OCI was born, so the Open Container Initiative. Most people, may know this, but from about 2015 on, Docker or other container engines that are OCI compliant rarely are actually doing the execution of your contained process. That's left to a binary called runc, an open source project maintained by the OCI. And so as soon as runc sort of came on the scene and Docker started using runc, Michael Crosby and some others inside Docker built this kind of shim layer between the full Docker engine and runc, and that was the initial Containerd code base. If you look back in our GitHub history, you'll see a branch 0.2.x. That's the code base that effectively was that start of Containerd back in that era. So Containerd at the time was really a runtime manager. So Docker said, hey, somebody called Docker run Containerd. Can you go start a runc process? Here's all the details. It built the OCI spec, which declares things like which binary am I running, which namespaces am I using, any C groups, so all these configuration details that if you're a developer, you think of those are flags like on Docker run, things I want to change to this user or, add this volume mount. All that ended up passing down through these layers, and Containerd effectively managed that runc layer. so again, kind of skipping a lot of exciting history in the container ecosystem at that time. You can go back and find tweets and blog posts. Docker is getting too big. Swarm is competing with Kubernetes, and so cloud providers like IBM and others were talking to Docker about maybe it is time for a more kind of stable core runtime. Docker has storage plugins and registry features and an enterprise product. Maybe we can segment out just that core runtime idea into its own layer. And so Containerd effectively moved from that 0.2 branch to the 1.0 sort of release time frame in late 2016. And that became the more full container runtime that if you install Containerd today, if you do the latest 1.4.0 or you're using Docker, which I think over the weekend updated to 1.3.7, this version of Containerd is now has full image support to push and pull images. It's not just a runtime manager, but it handles the content and the task management and metadata and all those things so that it can be a full runtime underneath Kubernetes, which is probably the most popular use case for Containerd. But there's still millions of Docker engines that use Containerd under the covers, again, to manage that runc layer of the actual processes being contained. So yeah, that's the whirlwind tour. You can find some talks on YouTube about, what is Containerd, where did it come from, and maybe a little more of that history. But that's kind of the quick version.
Excellent. You actually answered another viewer question there as part of that kind of summary there. Another question from Reddit was, why does Containerd exist when Docker, was a thing, even though they understood that Docker now uses Containerd? And I think the answer there as well, this was, at least in the initial version, was spun out of Docker to simplify that runtime aspect.
Absolutely, yeah.
Okay, so as far as Containerd goes and its touch points with the container ecosystem, you've mentioned Docker there. So Docker uses Containerd to actually orchestrate or run the containers. Kubernetes now uses Containerd as the default runtime implementation. Is there anything missing there that we haven't covered? Is Containerd used in any other large, substantial projects that's worth mentioning?
Yeah, so I think there's two aspects that I'm stumbling because there's a couple aspects to that. Because Containerd really has a API layer that's been very attractive. There's a lot of sort of consuming of Containerd across a pretty large number of projects that aren't necessarily just using it as a runtime, but consuming it in some other way or expanding on its capabilities because many parts of the architecture are pluggable. So I think, so one aspect of this whole thing is we could talk about all the cloud Kubernetes services that use it by default. We've already mentioned that. Linux Kit, which a project that came out of Docker, kind of a containerized, minimal secure Linux, uses Containerd as the core runtime. A lot of the sort of lightweight hypervisor or other advanced isolation capabilities like Amazon's Firecracker project or Kata containers, they've built shims. And when we look at the architecture, we'll see what that means. But they've built shims so that you can, again, drive Containerd through its API or from Kubernetes. And you can use these custom, isolation engines, gvisor, again, another option there. And then Cloud Foundry used to have a runc management layer, and they've effectively switched to use Containerd. So again, Cloud Foundry is a PaaS like Heroku. And so that's another kind of major user. And then, there's just a set of various vendor projects. So Alibaba Cloud built a tool called Pouch Container, which is almost like a Swiss Army knife Docker-like container runtime that, again, embeds Containerd and exposes all these features that Alibaba Cloud uses on their platform. And then Rancher did something similar when they built K3S. So this kind of minimized Kubernetes. Darren chose to build Containerd directly into K3S. So you don't even use a separate Containerd binary. Containerd is the runtime for K3S, and it's built directly into that single binary. So, and then, I guess one more that comes to mind, Alex Ellis built FASD. So again, part of his OpenFAS hierarchy of projects, FASD gives you a way to, you could deploy OpenFAS as a Kubernetes-based deployment, but you can also run FASD, and you're just effectively using the Containerd runtime to run your functions as a service in containers. So yeah, that, I'm probably missing some, but that's, people seem to be happy to kind of explore how to embed Containerd in other projects because of this simple kind of API layer. Actually, one other project that's worth mentioning, because you may already be using it, but BuildKit, which again is an open source project out of Docker. If you're using a very recent Docker, I'm not sure if they've made the switch where BuildKit is default, but it will be soon. But again, a container build engine that uses Containerd's API under the covers and can build directly with Containerd without Docker at all. So yeah, that's a handful of kind of Containerd using or exploiting projects.
That was a lot. There's a lot there. So, is now a good time then? Will we pull up this architecture diagram and you can give us the quick tour of some of those things you were talking about as well?
Yeah, absolutely.
All right, there we go.
Yeah, look at all the boxes. So I think one reason why this particular image is useful is you can kind of see ways that various tools kind of insert themselves at various layers of the Containerd architecture. One thing to note here that is important is that the Containerd architecture, that core layer in the, I guess, greenish, light greenish color, is actually built as a unique or differentiated set of gRPC-driven services. So all these services could be used by themselves. And the reason that's important is that there are people who have written libraries or uses of Containerd that replace, a specific service so that you can use, this construct even outside of using the Containerd daemon altogether. So, ORAs, maybe some listeners have heard of ORAs out of the Deus Labs team at Microsoft, but they liked the simplicity by which you could use the Go API for Containerd to talk to a registry. But they didn't want the content service to be writing or to to Containerd's content store, which you would need the Containerd daemon running. So they just you can make these calls and say, actually, my content service is just this place in memory over here or this file system. And now you can write a library that uses a piece of Containerd to do registry interaction, but you don't need the Containerd daemon at all. So there's all kinds of uses where any one of these gRPC services, so the content, diff, images, leases, namespaces, all these services are available. You could call them directly via gRPC, or you could write your own implementation and tell Containerd, actually, no, here's my implementation of content or containers or tasks. Most people aren't going to want to do that. They're just going to use it. They're going to go a layer up. So then Containerd has an API where it simplifies talking and meshing these services together. So you can think of like using it from Kubernetes through the CRI. So that's that left block of the Containerd API. You're calling, it's using a Containerd client Go API to do things like run a container, pull an image, and all those services are used by that API to do that. And again, if you've ever configured the Docker engine with a specific graph driver, like, I use overlay or I use device mapper, we call those snapshotters in Containerd lingo. And so again, we support a lot of the same ones you've seen before, but it's also pluggable. And that's interesting in that if you don't like any of these snapshotters, you can write your own. And there's some very interesting work. There's a talk from KubeCon a few weeks ago on the star GZ snapshotter, which does lazy image pull. And anyway, it can do major speed up in container startup time. So having the snapshotter be pluggable means you're not limited by the ones that we've thought up or implemented. And it allows things like, Windows to use their own snapshotter, their own implementations on that Microsoft has written. Stepping to the right of that, when you actually run a container, I talked about shims. Obviously the most natural shim is to call runc. I'm on Linux. I just want Linux kernel-based containers. I just want runc to run my process with the isolation I specify. But because our shim API is pluggable and you can extend it and configure your own, this is where you see Kata containers or Firecracker or gvisor, or on Windows, the run HCS tool or shim that Microsoft has built to run Linux containers on Windows as well as Windows containers on Windows. So the shims are down there at the bottom. We've talked about snapshotters, the pluggable content store, the array of gRPC services, and then of course above that, you can have container engines consuming all of this by using the Go library or calling the API. And so Docker does that. The Pouch Container project I talked about does that. Via the CRI API, Kubernetes does that. And then BuildKit, again, another consumer who also just says, I want to use Containerd as a client. I'm going to use the Go API to use their features for pushing and pulling from registries and so on. And then we have a simple administrative client called CTR on the far right there of the client. And that's, I think, the most important point for developers is we don't really expect that to be a replacement for the Docker command line. The Docker command line, of course, has grown over the years to have lots and lots of features. We're not seeing Containerd as a replacement for a direct kind of developer workflow. So CTR will probably feel clunky in some ways to a developer who's used to the Docker workflow. And there's a purpose to that because it's not really meant to be a replacement for your day-to-day use. It's more administrative debug so that you can test out Containerd. But we expect you're probably using it via some other wrapping tool like a platform. So that top layer, I'm using Azure's Kubernetes service. I'm using Docker. I'm using Rancher's K3S. All these use cases don't require me to use Containerd as kind of my main development tool, but Containerd is there providing the platform for these tools to then have a easy API for a container runtime. And so that's kind of the end result of what we talked about with the history, is that Containerd is kind of this stable layer that gives you all those features, but really is not meant to be a replacement for the developer workflow. I hope I did it justice. There's a lot there, but that's the bulk of how it's assembled and what the pieces are.
Yes, you definitely did that justice. I think I'm just in complete, not shock, but maybe awe of just the size and breadth of the project. When previously when I've always thought about Containerd, I think of the kubelet telling Containerd to go run a container for me, and it being such a small API surface. But really, there's a lot of moving parts and a lot of things that can be swapped in. I mean, just looking at the Containerd shims there, moving between runc and maybe Kata containers or Firecracker, like a lot of flexibility in this architecture that I guess is why people are adopting it for their own tooling.
Yeah, I think we've gotten a lot of positive comments about the API over the last couple of years. When Alex came and said, "Hey, let's can you help me figure out how I might use Containerd underneath FASD?" Weaveworks has used it underneath a few of their projects, and there's always a learning curve. It's like, oh, I didn't expect it to work this way. And I think there's another question that you got about documentation, which we can talk a little bit more about. But, it's hard to, as a small team of maintainers, to cover all the use cases and make sure everybody has the information they need to consume Containerd. But in general, you're absolutely right that people that have dug in a little bit say, hey, this is actually really easy to provide all the features I need for embedding or utilizing a container runtime in my project, and it just works. It's stable, it's simple, and so yeah, we're pretty happy with the comments we've gotten from people that have ended up using it for their project.
Excellent. I'm going to quote you that when anyone ever asks me how difficult is it to integrate Containerd into their project, it'll be, Phil said this is easy. That's the quote. Do you see a future where more, I don't want to say something's going to try to replace Docker as like a developer tool, but do you see more people using Containerd as base for developer tooling? I know a lot of people are frustrated with, local development tooling for Kubernetes. And do you see Containerd being the API that people start to adopt for things like that?
Yeah, I would hesitate thinking that Containerd will fully replace those kind of workflows. Again, we see it as more as an embeddable runtime. I mean, a couple of comments like I think there are a lot of people on Macs, for example. There's people using Windows and WSL2. And so, because Containerd is a Linux focused project, and of course we have Windows support as well, unless we find people who really want to dig in and build kind of another layer around it, you're not going to get the ease of like Docker desktop, where on my Mac, I've got this sort of streamlined, it feels like I'm running Docker commands on my, Mac terminal prompt, and I'm pulling images, all that ecosystem doesn't exist for Containerd. So if you're a Linux only developer and you're, building on a sort of Kubernetes ecosystem layer, then CTR as a tool may be enough for like what you want to do, because quickly you're going to go from CTR to using kubectl, for actually doing deployments or your Kubernetes based work. So yeah, I'm rambling a little, but I think I don't see Containerd really ever being that full kind of Docker ecosystem replacement, because again, Docker is more than just the container runtime these days anyway. One thing we haven't said officially here is that there is no CTR build. So you're going to either need build kit, or you're going to need Docker, or some in cloud, CI/CD build service to actually take Docker files or whatever your input is to build containers. Containerd has no container assembly code, build code in it.
All right, got it. So there was a talk you gave at KubeCon a couple of weeks ago, and there was a slightly different version of the architecture diagram.
Yeah.
Is there anything here we should cover?
Yeah, it's a good question. I'm getting old, so I'm gonna put on my glasses and make sure I can read this. So this is kind of it's almost the same view turned on its side, and it's trying to give a little more functional. I mean, we're trying to make it clear like how the pieces actually connect together. And so the client has been expanded, and we've kind of taken out the consumer part of it. So you can see like the client now helps you see, how do I actually access, what's behind this? How do I, so I configure my client with some options. How do I connect to the gRPC socket? How I subscribe to events. For containers themselves, I pass in options. I get an OCI spec. And then these proxies, that's the actual gRPC traffic across that boundary to the containerd 1.x API. And so that kind of, it looks duplicated, but that helps you see that, like on my client side, when I say CTR run, that task service will talk to the task API and then use the actual implementation on the server side, which could use a series, it's going to use the images and snapshots service to assemble the right root file system to actually call the task manager to start a shim if I'm using runc by default. So this view, is easier to talk through the flow of like, how does, CTR run actually turn into a series of steps that gets me a running runc shim at the far right side. But there, as far as the API, the great news for consumers is like we have not had to break that gRPC API for 2 years now, and so we hope that this API is extremely stable. That if people need functional differences, they shouldn't be coming to us and say, "Hey, please change the containerd API." They should be looking at the pluggability of this core and saying, "Oh, I could do that. I need a different shim because I'm trying to do some fancy thing at the runtime level, or I need a plugin for snapshots because I want a new way to like represent the file system, or I have this cool file system that you guys don't know about in my lab, and I want to utilize it with a snapshotter." So yeah, I think the main point of this is that actually one more comment: the API layer, you see the CRI plugin. So one thing I didn't mention in the history is that containerd was initially built without an implementation for Kubernetes CRI, which is the container runtime interface. So that is a separate gRPC API defined by the Kubernetes community. If you're interested, SIG node is the Kubernetes special interest group that deals with the CRI API, and it does evolve over time. So a set of sort of separate maintainers built a CRI plugin for containerd. And so you can find 2 different GitHub projects. We brought them into the containerd repository several years ago, but we're now actually for containerd 1.5, we plan on actually bringing their code into containerd. And so this plugin continues to get more tightly integrated. So if you're using containerd 1.2, 1.3, 1.4, that binary does have the CRI plugin built in. The code base change is just to continue that natural progression of we're all maintaining the same code, we're all working together, so the CRI doesn't need to be a separate project anymore. So again, that just by default, that gives us makes us a Kubernetes runtime. The kubelet can talk to the same gRPC socket and talk that CRI API directly to containerd. So yeah.
Excellent. I think there's definitely a lot to unpack there with both architectural diagrams and the different components. Really cool that kind of CRI layer and API layer are maybe going to consolidate. Does that mean that containerd then becomes a competitor with cri-o?
Yeah, I always try and be careful when I think a lot of folks want to see kind of sparks fly between containerd and cri-o. Cri-o is really had a similar vision to containerd in that Red Hat and Docker had some competitive disagreements over Docker's kind of future, definitely around Swarm, and other issues around distributing Docker and Red Hat distributions of Linux. And so cri-o had the same idea of kind of this core runtime built on some building blocks. And so if you go look on GitHub, you can see a project containers/storage. That's actually a copy of the Docker graph drivers implementation from like old Docker 1.12, 1.13 era. And then Red Hat continued to develop it and of course officially maintains it today as an open source project under that containers repo. So there's containers storage and containers image. And what you'll see is that Red Hat has built a layer of tools on top of those two projects. So it's not just cri-o, it's Podman and Builda and Scopio. They all use this same layer, and that gives them the ability to say, hey, our tools are actually not dependent on a daemon because they're all using this same container storage file store. They're all using this containers image library for talking to registries. And so all this can happen like kind of in the tool itself. Cri-o is not necessarily daemonless in the sense that the kubelet has to have a CRI socket to talk to. So you have to have some listener somewhere. And so cri-o does have, these small daemons that listen for the CRI API and to do some monitoring of the processes. But it's really born out of the same time frame as Containerd, and as a very personal comment, not representing IBM or Red Hat or Docker, there was definitely personally a hope that we could rally around one or the other, and of course, naturally, Containerd was my intention to convince them to work together on that. And the cool thing is that we've shared code over the years. They import some of our sub packages and use Containerd code for some things. And so, at the maintainer level, we've always had good relationship and worked together. But to me, I hope it's becoming more like, some people use Firefox, some people use Chrome, maybe on a Mac, you like Safari, they are competitive in a general sense that you have to make a choice about which kind of community you're going to use or get involved in, but they're just options. They're just options that are out there. And yes, there are some differences in kind of the design, but that's where I see it today.
All right, awesome. It's great context there just to understand how those two projects fit. And with the CRI there and the OCI stuff, like the compatibility is there for people to
exactly
have a preference.
Yep.
So we have one more question, and then I think what we'll do is we'll jump onto the hands-on component of this session. And the question came from Reddit again, and it was, what are some best practices while running Containerd via systemd? That seems like quite a wide scope, so I'll let you, if you want to tackle that.
Yeah, hopefully I'll answer the right question, because there's not really, I'm not sure if they're asking if there's kind of a strong integration with like the way systemd manages processes, because there have been methods, and I know some people still use these, where systemd is much more integrated in actually the spawning and management of container processes. That's not the case with Containerd. So we have in our repo, and I believe it's delivered in our full release tarball, a systemd unit for Containerd, and that just means that Containerd will be started on boot, with other system processes. At that point, that's really the last sort of interconnection with systemd. There's no other management other than the way systemd manages, units on the system. You can start it, you can check its status, etc. So I don't know if that's the question being asked, but today that's kind of our interaction with systemd is, if you're on a systemd controlled Linux distribution, then Containerd's unit will make sure that Containerd is started, but Containerd at that point will manage its own processes that are run via Containerd. There won't be any integration with systemd as far as the spawning of containers at that point.
Okay. So just a question that popped in my head then, as you were kind of talking about that. Are there any rules around restarting the Containerd process about how that would affect running containers, or is it pretty seamless?
Yeah, it's there shouldn't be any issues with restart. Similar to how over the years Docker matured to where it's not going to crash all your containers. You're not going to lose state. Containerd will restart and try and reconnect to the shims. So that's one of the reasons the shims exist. The shims are the parent of your actual containerized process. And so if containerd goes away, the shims thankfully are still parented. It's still parenting your container. So it's not going to wipe out. I don't know if people remember in the early days of Docker, you crash your Docker daemon, you lose all your containers. That's not the case. So containerd can restart. It'll go find all the shims, and you should, unless there's a bug or some other complicated issue, you'll still have access and management of the containers that we're already running.
Nice. All right, let me share my screen then, and we'll kind of let's actually play with this, right? So, what I have in front of me is a Linux machine on Packet because I run a Mac, and that's not going to work. So, I have got snap installed, and I went ahead and ran snap install micro-k8s classic. I have done this at your advice, as you said that micro-k8s gives us access to the containerd tooling as well as access to containerd running as the CRI implementation for Kubernetes. So that's all I've done. I've not done anything else. What do I do now?
Yeah. So in true internet fashion, we're flying by the seat of our pants because I haven't messed with micro-k8s in a little bit, but just to give people a quick flavor, this is Canonical's kind of like Kind. People have used Kind, where you kind of have a single node Kubernetes distribution all in one, which means, of course, you've got the kubelet, you have your single node is now everything. You're the master, you've got a kubelet, you have a container runtime, and it just so happens that micro-k8s uses containerd as their runtime. And so we should, at this point, have a running containerd, and we should have the CTR tool available to us. So yeah, if we're lucky, this should show us, so we can see the path there is inside this snap of micro-k8s. It has its own var lib containerd, and that seems to be running. And yeah, we can actually see some shims because, again, this is a Kubernetes deployment. So there are actually some containers, as you know, if you start up Kubernetes, you have some kube system containers, pods that are already up and running. So I don't know. Yeah, go ahead.
So based on what I kind of picked up then on the API surface of containerd is that I should, although we're not recommending it as a daily driver, be able to pull an image and run a container using CTR.
Yeah, so let's see if CTR is in your path. I can't remember if you have to do micro-k8s.ctr or...
Yeah, you do. But I do have access to CTR. So.
Okay, yeah, great. One of the things we should talk about at this point is that containerd, unlike the sort of default Docker model, is that every bit of content and metadata is namespaced. And so maybe do a CTR space namespaces ls, or ns works as well. So you can see that there's already a k8s.io, and this means that micro-k8s deployment is actually, whenever it runs containers through the CRI, they're getting placed in this k8s.io namespace. It's kind of cool because now if we use CTR from the command line and we don't want to mess. Now, again, there's nothing. This is really administrative. There's no security being applied here. There's no RBAC. That's all handled at higher layers. But we can do. We can basically create a new namespace. So we could create one called default or Rawkode. I think it's just create and then a name.
Yeah, I'm just assuming that was going to work. So.
Okay, so now if we do the ls, we have Rawkode. Now, every other command takes a -n or a -- namespace, which gets really annoying to type. So if you export the containerd underscore namespace equals Rawkode environment into the environment, then basically, now if we do a microcade CTR containers or just C by itself, ls, we'll see. Now, why do we see containers? I was about to say we shouldn't see anything because we've exported our namespace.
Did I mess up the export?
It looks right. Container D namespace. So let's try, just bring back the CLS command and preface it with dash before the C. Just do -n Rawkode. And what did I do wrong? Oh, cannot two forms of the same flag. Does that mean it's reading the environment?
Yeah, that's what I'm kind of getting from.
Yeah. Interesting. Yeah, that's fun. I can't think of why you're seeing. Yeah, I think CLS should be namespaced. Oh, you know what? I think we're having fun with microcates, doing something default behind our backs. I think they're setting the namespace for us so that we get the microcates environment.
Okay, that makes sense.
Yeah, so that's kind of fun. I don't know if there's a way to tell microcates not to do that, but that we can still play around. We don't.
Yeah, we'll just ignore it.
Yeah, we'll ignore it for now. So yeah, that's the fun of using somebody's sort of embodiment. So yeah, these are the pods that are running, via the microcates environment. So let's pull our own image. So
can I ask a question?
Yeah.
So is the pod a native concept in Containerd rather than a container?
No. So again, we implement the CRI, which has some of those concepts, but it doesn't require the runtime itself to have those concepts in its own. So if you go back and look at that architecture diagram, it just thinks in tasks and containers. There's nothing on here that says there's no metadata type called a pod. And so it's really the CRI plugin that has the knowledge that, oh, these two containers are in the same pod, so I need to share the network namespace and UTS namespace, etc. So yeah, Containerd's core code base does not have the pod concept.
Okay, perfect.
Yeah, so I guess just to show the pull and run scenario, we can do CTR images, and then it's pull. And the only difference between like the way you do it in Docker is you need to fully specify. So there's no default to Docker Hub. So you need to preface that with docker.io/library because it's actually in the core library /nginx, and you have to add a tag. Like we don't let you do so :latest is fine. So you fully specify the exact image. It's going to pull the layers, and it will unpack the one for your architecture if it's a multi-platform image. So it says, okay, your Linux AMD 64, and now you have that image locally. And so you can do a CTR images ls just to kind of see. And it's a little messy because it's showing a lot of detail around the architectures that are supported, the media type of the image. Again,
large font wouldn't be helping either.
Yeah. So, but if it's hard to see in here, but if you grepped on your Nginx, you'd see that we've officially pulled the Nginx latest. Yep. And that it was a multi-arc image. It supports all those platforms, but it only unpacked the Linux AMD 64 image. So now we can run it. And the way we do that is just a CTR. We actually have a simplified run command, but yeah, container run works. Actually, yeah, run. You don't need to specify kind of the object type. So CTR run by itself without the container.
Do I need to fill
Yeah.
everything?
So, no, you don't have to fill all that. Actually, yes, you do. I'm sorry.
Let's just see if I break it then.
Yeah, yeah,
Oh, I need a container ID.
yeah. So you have to name your container. We don't have the fancy fun like default names like Docker. So
Well, I feel it would be remiss if I didn't give it a name in its vein, though. So let's call it Angry Linus.
I think, yeah. So there's no. It actually just takes positional parameters. So the -n isn't needed. So just give it. I'm trying to think if there's an order here that I'm forgetting. So the image, and then there is a default command. You don't need to specify command in args. So the ID is the last. So did you get an error? I missed it. You should just be able to specify a name after the image. Oh, but you'll need the Docker IO/library in front of Nginx.
All right.
But again, there's no default to Docker Hub. You're gonna you are sudo. Well, that's fun. You are as root.
Just a weird micro case thing, probably.
Yeah, but again, they may have made some changes in microcates to kind of keep you on the farm, like not off running random images. So I'm sorry, I should have messed around with that too, because I will take credit or the fall for recommending that we use microcates just as a simple way to get container D.
All right, let's just snap uninstall microcates. What's it on? Let's remove. Spell it right. We'll get there. And then we'll just do a curl get.docker.io.
Yeah, that'll give us a container D instance that should actually start it for us as well.
No, it's not fast at removing things, is it?
Yeah, it actually has to stop the kubelet and the container engine and stop a bunch of pods, and it tries to do it.
I guess I don't really need it to go away, so let's just
Yeah, I mean, the snap is actually not going to get in the way of the standard container D.
well, it's not listening to my wonderful signal, so I
Uh,
will grab this IP address and I'll just SSH. Was that the same one? Oh, of course it comes back right there. Right. So curl https get.docker.io and we'll just okay, let's just save it. Have I got that wrong? Get.docker.io. And just copy it from here. And get Docker. There we go.
There you go. Yeah, so that's interesting. I was chatting with the microcates folks now and then, and seeing if I could use it for kind of as a standalone container D. But it's been a while, so maybe something has changed with that.
All right. Yeah, I mean, I've used microkits a few times. It usually works pretty well. I'm sure it's just something silly. But we can quickly get back to where we were. So we pulled the
Yep.
Nginx latest image, and in theory now I should be able to do run, and it was Docker IO library Nginx latest, and then Angry Linus. Ta-da!
Yep. There we go.
Okay.
So a couple things that are worth mentioning. So that can be disappointing for folks. Docker defaulted or had a default implementation of a core kind of networking implementation because Containerd was built in the context of just, again, this core, like run an OCI image, take the spec, create the right namespaces. There's no default like IP forwarding, bridge, all those pieces that people kind of expect out of the box because Docker had it. Kubernetes doesn't need that, right? Because you've got a CNI plugin providing that networking layer. So this Nginx we just built, there's no way to like talk to it because there's no IP address in this container you just started. There are some fun tools people have written. You can kind of add that on your own. You can mess around with that. Or again, you can use it via another layer and you get that to however that other layer provides it. So, if people want to play around with that, Michael Crosby has a nifty tool called BOSS, BOSS, that wraps Containerd, adds some management. I think he runs like his kind of personal network services and system using BOSS. It has some nice restart and checkpoint features. So again, Containerd is really built as something you build on top of, and so there are things that just don't come out of the box, such as networking by default. Yeah.
I was going to say, like, you said earlier, and you've kind of reset it again there, that this is not a tool for people sitting in front of a computer that want to run containers. And I was thinking, but CTR run wasn't that bad. And then, bam, there's no networking, there's no volume system. Okay, maybe not something I want to do then.
Yeah. Yeah. And again, with the CRI plugin as being one of our primary use cases, you can think, well, if I put that in Containerd, I'd be duplicating things that the Kubernetes layer already does for me. And so that's some of the thinking behind that is, I don't need those features because the layer above me is going to provide those. And, it's a good point, especially for that Kubernetes use case, because I know for a fact that it becomes a security issue to some consumers of Kubernetes services when they find out, oh, you use Docker as the Kubernetes runtime. What do you do with the Docker default bridge? Because it shouldn't be used, but it's there because Docker created it when the daemon started. And so people that use the Docker engine as a Kubernetes runtime, you may be asked in a security audit, have you removed the Docker bridge because your containers are being connected potentially to two different networks, the Kubernetes CNI implementation you use, but also the Docker default bridge. So again, not having that in Containerd is one less thing that you have to monkey with because there's no default kind of network implementation.
Right, got it. So we're approaching the hour now, and we have a few more questions that were submitted via Reddit and Twitter, which I'll run through if you're happy to, and then we'll wrap up for the day. I think that's
cool. Great.
So the first question I have now is, how do I debug Containerd issues? Which log files should I look in, and how do I fix it?
Yeah, so if you're in charge of running Containerd, the daemon, there is a log level setting that if you do, -d on Containerd, you go into debug mode and you get significant volumes of information on events, on the API, on registry interactions. So obviously, if you're able to restart the daemon, reproduce your issue in debug mode, that's almost always a valuable source of, what happened, why didn't this happen, and what was the error, why did the daemon say my container couldn't start or the OCI runtime failed. So that's kind of step one, run your daemon in debug mode. Going to be a little trickier if you're a consumer of something that's using Containerd, how do you get them to turn containerd into debug mode? So that may be a secondary thing you have to figure out. If again, that depending on your setup, where that actually logs when you're in debug mode, as a developer of containerd, I'm just running containerd in a separate terminal, either piping to a file. But if you're running via systemd, you should be able to extract the logs using the journal, commands for systemd. If that's not producing the information you need, say you have a hang, containerd seems to not be responding to the API. Similar to Docker and other tools written in Go, you can send a sig user1, and there's actually a keystroke you can do if you're running containerd in a terminal. But if you send the signal, and the cool thing is our shims support it too. So remember that the shim is a separate process from the daemon. You can send both of them a sig user1 and get a full Golang thread dump, process dump. And a lot of times, we ask people reporting issues about hangs or unresponsive containerd to GitHub. We ask them to send, that signal and send us the Golang routine output. And a lot of times you can see, your root file system isn't going away, like when we're trying to clean up your container, and there's the shim process is waiting for that to happen and it won't return. So again, the Golang output can be really helpful for debugging containerd, as it's useful for other Go-based tools as well. So yeah, that's probably, those two things are going to get you 99% of the way. People working at a much lower level, you're building the next gvisor kata containers and you're down in the bowels of kernel interactions. There may be other, obviously lots of cool things that are happening with eBPF and tools that, track syscalls, that if you're down at that layer, there are probably a series of BPF tools that can be valuable to figure out things like, there's a seccomp profile blocking my container from using a certain syscall. That's why it's not working. But that's going to be more BPF layer related.
Nice. That was an awesome answer to a very vague question. So the next one I'm going to try and abridge it for you. It's quite lengthy, but the premise of the question is there seems to be some discrepancies between a V1 and V2 configuration schema. Now, I'm not sure what that is, so maybe you can clarify that.
Yep.
But the question is then, are there any plans to improve the documentation around that so that there's not those hurdles for people adopting containerd?
Yeah, that's a good question. So I'm pretty sure they're referring to containerd's TOML configuration file. So like most daemons, you can run it with a default config. You don't ever have to look at it. It probably is going to do, when you just installed Docker and you got CTR and containerd running, you didn't have to create a config TOML file because Docker created one, containerd started, and you didn't have to worry about those settings. Because containerd has this plugin model, and there are a series of switches, turn this on, turn this off. Over the years, we chose TOML. It's very simple, descriptive language. Has some similarities to YAML, of course. But over time, we found that as we were adding features to containerd, especially around registry, authorizer support, pull through caches, all these kind of fancy configuration options, and the fact that each plugin can have its own section in the TOML file. We found that what we had started with was just going to be too simplistic to handle some of the capabilities we needed. And so there's a new TOML format that the parser in containerd, if you have version =2 at the top of your containerd config, which is now the default, it will be read obviously as a version 2 config file instead of version 1. And I think the feedback is right on that, like, maybe we haven't, again, there's a set of users who will never care about those things and never have to worry about it. But for the people that do, I think it's absolutely correct that we have struggled to keep up all the documentation, all the avenues that people come to Containerd to be able to find the right documentation for that version 2 config. We've been talking to the CNCF about, and I think I don't know if it was part of this question that you had shared with me, but, because there's so many use cases for Containerd, there's the Docker use case, the Kubernetes use case, it's embedded in this other vendor tool. It's been hard to kind of cover those broadly from a documentation standpoint. And so we have been trying to get more help to raise the level of documentation that can start with, how are you using Containerd? Oh, you probably want to start with API docs, or, oh, you want to see how to configure it in a certain way. And so, bear with us. We're we're trying to get there. It's an open source project, so as you know, it depends on the level of commitment from folks. We've had people say, "Hey, I want to help with docs," and then they got busy with other stuff. So yeah, we're still looking for people who'd love to help us improve that area of the project.
All right, awesome answer again. We've got one final question, and I'll read this one out because I'm not sure I understand this one. So someone has asked if it is possible to transparently use mirrors for all kinds of registries. Now, they provide an example. They want to use a pull-through cache for Docker.io, cri-o, the GCR repository. They say that they have tried this in the past. However, they run into problems with certificates and authentication. Is this something that has changed or gotten better recently?
Yeah, there has been, and I don't know how long ago or which version of Containerd they tried. Containerd 1.4 just came out, which I think 1.4 is maybe the first version that has like a rework of how you configure registry connections, I guess is one way to say it. But the certificates, the authentication, which order to visit registries in when looking for an image. I just found an issue from 17 days ago, Containerd issue 4531, if people want to go look it up. But it shows some of the plugin configuration for doing registry mirroring. And so definitely it's supported in Containerd. It is a complicated area because, you're having to set up a series of registries and then all the authentication information. I want to say, I hope it's a lot better in 1.4 than it has been. It's been an area that we've focused on. It may be an area where we need, I feel like I see a lot of issues around this. And it also is a point in time. So some registry implementations aren't really following the OCI spec well. So we've been trying to resist adding tons of if else. Oh, well, this is Artifactory and they do a 403 on this, and then you got to respond with this. Or, oh, this is Docker Hub and it expects this series of events to happen. So we've had people from GitHub registry come work with us in the community to make sure their implementation works with Containerd, which they just got the GitHub container registry working well with Containerd in the last month. So it's a growing area, I guess, is the simplest way to put it. If someone's really stuck, please come to the repo, open an issue, because there are people smarter than me about kind of how the fallback and mirroring configs work. And then finally, hopefully our documentation keeps improving that you can, say, hey, pull through cache, where's the doc on that? And how do I get it set up? And hopefully we'll have a place that gives you the lowdown on making that work.
Awesome. Thank you very much. we are all out of questions. I just want to say thank you very much for taking the time out of your day to join me. This has been really helpful for me to help my understanding of Containerd. I'm sure it's going to be very helpful for loads of other people. So thank you very much, Phil.
Yeah, awesome. Thanks for having me.
No problem. All right. Have a nice day, and I'll speak to you soon. Thanks.
All right. Bye now.